three lines x equals 0, y minus z minus 1 equal to 0. Okay. One line is this, second line is, I think answer is 1. Okay. Next. You want me to tell you the answer or I should solve, right? Okay. 26. A square is inscribed in a circle. If P1 is the probability that a randomly chosen point of a circle lies within the square, and P2 is the probability that the point lies outside the square. So 2R is diagonal, A is the side, let us suppose. So root 2A is equal to 2R. So A equals root 2R. Am I clear? The point lies within the square. So P1, if I talk about, so it would be a kind of a geometrical probability in which you'll have P1 is, it should lie in this region. So P1 would be nothing but total area is pi r square, and this area is side square A square, that is 2R square. So 2 over pi. You understand that? And P2 is the probability that the point lies outside the square, means 1 minus 2 over 2 pi. Can I say that? This is your P2. So naturally 2 over pi and 1 minus 2 over pi, you can very well see that it will be a 2 over 3.14, and is, when you do division, approximately 1 minus this value will be, this value will be, compared to this one, is smaller. P2 is smaller than P1. So this will be your first answer. A. This B is the answer. This is wrong. This is wrong. That you can check out by squaring and subtracting. Yeah. So next. Tell me. $33. You want me to tell you the key or you need me to solve? Yeah. A group of students comprising of 3 girls and 5 boys. Okay. Went for a picnic. During the game, they are arranged in a circle. The probability that each boy has one girl on at least one side. Okay. So first of all, let the boys will set. Okay, 5 boys being settled in 4 factorial ways, and 8 minus 1 factorial is, I want that girls to settle down now. How many possibilities of girls to settle down? Every boy should be, okay, this is B, B2. Now I have to just make the girls to sit, 3 girls. Possibility number 1, girl come here. They have one girl on their side. I'll keep one girl here. Okay, and then I'll keep one girl here. Okay. Understand, this is 3 factorial ways they can set. But this 3 factorial will have multiple possibilities. Like right now they are between B1 and B5. Then you have this one may clash also. Like instead of this, I'll take it there. Then bond possible. Yeah, it is possible. Take this as well. 2 possibilities. What do you understand by that? Means, please make the cases, you'll understand the cases. Like B1, B2, B3, B4, B5. I will make the girls B1, G1, G2, G3 in such a way that 2 should be adjacent, means should have exactly one boy between them, and another one will have exactly 2 boys within them. Then you rotate like this. You understand? So how many cases you will get it? T1, one case is starting with this. Here I'll make it. Or shall I make it like T1, T2, T2 together? And if G3 will set somewhere else, here, not working. One over 7 is the answer. So my concern is that I just want you to take up like it's a pentagon being formed, or a octagon being formed, and the girls are to be settled like this. In that they should not be means the cases we have to make it like that there should be exactly one boy within 2 girls, and consecutive third girl should not be there. 3 girls should not be having exactly this one. Total out of that we subtract. Let me do by that and see the answer comes. I'm making total cases possible, that all possible cases of making the girls to set after boys being settled, 5 factorial multiplied by, not 5 factorial, boys are 5, so 4 factorial multiplied by 3 girls. Now within them we have 5 choices. The girls will go and sit, and that any, we have 5, 4 and 3, sorry, 5p3. So these are the girls being settled. Okay, out of that I want to subtract those cases in which the girls are consecutive. If the girls are consecutive, there won't be a possibility that every boy will have one side, at least one girl. So all consecutive cases I will subtract. All the 3 girls not together. At these places I have taken, the girls I have taken on these places only. Out of that I want to subtract that the girls should be in consecutive location. Like one boy in each within them. So what are the possibilities of them? That G1 comes here, G2 comes here, G3 comes here. Then you have G2, G3, G4. You have 1, 2, 3, 2, 3, 4, 3, 4, 5. How many cases are there? 5 cases, I think you will get it. Because 5 spaces are there, na? So that 5 cases multiplied by 3 factorial. Yes. So this cases should be subtracted. So 5 factorial by 2 factorial multiplied by 24. This is your 60 minus 30. So 20, 48 minus, this is correct. Yes, we got the answer now. See what I'm saying? Everyone, pay attention. What I'm doing, you can see very well. First of all, let the 5 boys should settle. Okay. 5 boys will settle in 4 factorial ways. I want every boy should have at least on one side a girl should be present. So what are the cases on the contrast basis is that if all the 3 girls sit alternately, then there would be the possibility that we won't find the boys, these boys. Let me make it again. These boys will be having girls on their side if they are consecutive. If girls are consecutive here, then these B1 and B4 will not fulfill the condition. But other way around, if girl will sit here, then this will fulfill the condition. Means rest of the cases, the condition will be fulfilled. Understood what I said? So what I want that these consecutive cases to be subtracted from the total possible places in which the girls can settle down. So what I'm doing is that first of all I'm making the boys to sit, then I'm making girls in between spaces which are 5 to come and sit over there in 5p3 ways. I'm telling open way. They come and sit over there in a linear permutation ways because I numbered the positions. The girls will come at 5 position and sit, out of which I'll subtract those cases in which girls are consecutive. Means at this position, we have in between boys 5 positions are there. You understand 5 positions? In that 5 positions, girls will come and sit like 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 1, and 5, 1, 4. Sorry, 4, 5, 1, and then 5, 1, 2. The next will come the same one. These are the 5 cases in which the girls are alternately being settled down. So they will be 5 cases, right? In that 5 cases, 3 girls have 3 factorial ways of sitting. So that girls 3 factorial ways, I'll subtract that. So 5p3 is nothing but 60 minus 30 into 4 factorial. You have 30 multiplied by 24 over 7 factorial. It is 720 only, which is nothing but 6 factorial. So we have 1 over 7 as an answer. Am I clear? You understood what I said? Consecutive and this one which is to be contrast way to subtract. Now move to the next. See this PNC probability, that will definitely take time, because in that case now some uncertainty is also there that we might have left 1 case or 2 cases. Unless you do more practice, you will not get that confidence. So keep on practicing, keep on doing the questions. Yeah, tell me which one to do. $38. Answer is known. 38 answer is B and C. Let us see. 38 are these probabilities 3 mutually exclusive events. And P may be. This is the question which normally being done. Like you have to take first, everyone is a probability. It should lie between 0 and 1. Then you have another mutually exclusive 1 plus 4p over 4 plus 1 minus p over 3 should lie between, because it is PA union B union C, which is PA plus PB plus PC. Are you getting my point? And the answer of this, common of that, will be the final answer. You got it? You get the range of P and you have to see which one is going to match with that. The answer is B and D. You want me to solve? Okay, go ahead then. $48 key is A is T, B is Q, A is T, B is Q, C is S and D is R. Yeah, tell me. $48D. Let P, Q be chosen one by one from the set with replacement. Now a circle taking P, Q as its center. The probability that at most 2 rational points exist on the circle? No. For the yeah, for it to be rational, the center has to be rational. The one story is that for a center of a circle and would be like pi comma e. There is one question on this also. How many rational points lies on a circle with center as pi comma e? So we get the answer that at most one point will lie on a circle with center pi comma e. Irrational, I'm saying that irrational coordinates of a center being there, then how many rational points will lie on the circle would be at most one. Yes, in that case. Now they are saying that P and Q should be chosen from this one by one with replacement, and a circle is being drawn with taken P and Q as its center. The probability that at most two rational points exist on the circle means the P and Q both should have to be rational. So we have two possibilities, right? Not exactly. So zero rational won't be there. Rational will always be there. Minimum one to always be there. If you have 1 and 2, then there would be maximum 2. So you have the possibility 2 multiplied by 2 over 3 multiplied by 3. 6 plus 6. And another case is if you take आ रहे क्यों? We'll take one thing. We'll take up a triangle, a circle with center as 1 comma root 2, let us suppose. Okay. So x minus 1 whole square plus 5 minus root 2 whole square is equal to r square. The circle, right? So now, how can you just judge the value of x and y which is lying on this to be rational? R square is a rational number. This y should be either 0 or combination of root 2. Right? To give r square as rational. But in x, so you have infinite. There should be some radius they should mention in that case then. How will you get this then? There is one question which is there, I still remember, with pi comma e as the center, you get at most one rational point on it. But for at most 2, what is the status to do? My concern is this. When both are irrational, you know very well take any 3 points. The centroid or circumcenter. Yes, what's your thought process? What is your opinion? What you have done it in this? See, if radius is not there, that is pretty difficult to judge that, to get the rational points. Like in this case, I was having in my opinion that unless and until both are pi and at most 1 or 0, 0 and most 1. How will you get 1 in this case then? No? If we take up the example, so A not clear. Without radius, how can you check? With radius or if I expand, okay, let's do that within. Okay, let's do the expansion for this also. Hmm? Radius may be irrational also. What can you say about that? Radius is not clear, then how can you judge? If you take a triangle, anything possibility by triangle? You remember that if the triangle has rational coordinates, then it's O, G, H and I. I may or may not be rational, but rest are rational. This is the story behind the triangle, because every triangle has a unique circumcircle, na? So I'm taking, let 3 points x1, y1, x2, y2, x3, y3 all are rational, then O, G and H must be rational. So center is your circumcenter must be rational if all the 3 are rational. So this is the story behind that, what we already studied. Why is it so that you can calculate that this equation will have all rational commitment if both are rational? This equation has all rational commitment, this also have rational commitment. When you calculate they are rational, so the circumcenter will automatically become rational. So center we are talking about, if all the 3 are rational, you will have center as rational only. For center to be rational. So we have at most 2, so that case will go that we cannot take 1 and 2. So if you take one as 1, another as root 2, what is the story behind that then? The O is irrational OG is to GH is 1:2. You remember that? So G is being formed by this summation. That is a rational. OG is going to be irrational value. Okay. So not as such conclusion coming with this. Total minus all rational, we subtract, then what is the answer? Means so both rational you subtract, na? So that was 4/36. 4/36. 8/9 would be the answer. See, this you can do by method of elimination then. What we conclude is that if O is rational, all three are rational. If O is irrational, all three cannot be rational. There would be 2 or 1 or 0. This is the story. We can say that. Do you agree or not? So, we don't want to make the center as rational because 3 rational points will come. We want at most 2. It is being mentioning at most 2 rational points we need. So what is my story is that we should do contrast of it. Contrast means taking center as rational and subtract from the total will give either 2 rational points are there on a circle which forms a triangle which is having a circumcenter irrational, or 1 or 0. So I'll take this case as a method of elimination. 1 and 2. You can see very well 1 and 2. To check, to select P, you have 2 choices out of 6. To select Q, you have 2 choices out of 6. So you have 4/36 means 1/9 to get a rational center. Means 3 points rational. 1 minus that will give you 8/9 means all the 3 cannot be rational. You understood what I said? This is the only possibility which we can go for. Yeah.